Okay, so this week, in this second half of the chapter, we are going to start looking at what happens when we end up with a negative under the radical. So if we look at this equation we have right here, we would say we would subtract 4 and we would get x squared equals negative 4. And up until now, when we took the square root of both sides, we would have said no real solutions. Well, now we are going to figure out what we do so that we do have a solution. Okay, so if the number under the square root is negative, then we said, again, there is no real solutions. However, we can define an imaginary unit, which we call I. That way we can actually deal with these negatives, okay? So what we need to know is, what does the I actually mean? And what is its definition? So by definition, okay, the square root of negative 1 equals I. And then the other way, if you squared it, if you did I squared, you would have negative 1. So those are the two things that we need to remember and keep in mind as we move forward with the rest of this unit. Okay, so let's start just by simplifying some radicals and what that actually looks like. And this looks like it didn't exactly copy very well because there's supposed to be a negative underneath of there. I apologize. So if we are going to simplify the square root of negative 25, there is actually a solution for that. And what we're going to do, I like to break my square roots apart. So this negative right here is going to be the square root of negative 1. And this is going to be the square root of 25. So all I did was I broke it apart. Negative 1 times 25 is negative 25. Well, we learned on the last slide that the square root of negative 1 is I, and we know that the square root of 25 is 5. And when we break it apart, we're just multiplying together, so we would have 5I. So basically, by taking the negative out, we pull out an I. That's what I always like to say. We're pulling out an I, which that would be a bad idea. So anyway, so this one, again, if you can see that, there's supposed to be a negative right there. It just did not copy very well. So again, that negative is the square root of negative 1, okay? And then 72 is not a perfect square, but it does have a factor of 36 that's a perfect square, because 36 times 2 is 72. So if you think about those things, they're all being multiplied together. I know that the square root of negative 1 is I. I know that the square root of 36 is 6. And I know, well, the square root of 2 is just the square root of 2. And we are multiplying those all together. So when we write it, we are going to put 6I times the square root of 2. That's the order that we're going to put them in. We're going to put a number coefficient, and then we will put I, and then we'll put our radical. Okay, let's look at this next one. We have a negative 5 out here. A negative 5 is not under the radical. A negative 5 is just a negative 5. Okay? The square root of 9. That negative is the square root of negative 1, and 9 is going to be the square root of 9. Okay? Again, when we break it apart, it just means that those three things are being multiplied together. And we have negative 5, doesn't do anything. The square root of negative 1 we said was I, and the square root of 9 is 3. And negative 5 times 3 is negative 15 times I. Okay, and again, these two over here most definitely did not copy well. So this one has a negative on the outside. This second one here has a negative on the outside and on the inside. So let's see how this looks here. If we have a negative on the outside, that's just going to stay a negative. The square root of 36 is just 6. So we are just going to have negative 6. Okay. The second one, I said we wanted to have a negative on the outside and the inside. So we're going to have a negative. That negative is the square root of negative 1, the square root of 36. And that negative stays negative. Square root of negative 1 is I, and the square root of 36 is 6. And when we write it, we always put our coefficient as a number first, and then we write our imaginary second. Last one here, We've got 2 times the square root of negative 54. Again, 2 is just 2. Negative under the square root is the square root of negative 1. And 54 can be simplified because it does have a 9 times 6 is 54. So we could break that apart into the square root of 9 and the square root of 6. And again, these are all being multiplied together. So 2 is just 2. Square root of negative 1 we said was I. Square root of 9 was 3. And the square root of 6 is just the square root of 6 because we can't simplify it anymore. What's on the outside here is being multiplied together, which means 2 times 3i is 6i. And then that square root of 6 stays underneath. All right, let's move on. Okay, so the next thing we are going to do is simplified with negatives under the square root. Now we are going to just add and subtract. And adding and subtracting is fairly simple. Basically, it's just like combining like terms. Your real numbers are like terms, and your imaginary numbers are like terms. And you're just going to add them together with your coefficients or just as regular old numbers. Okay, so let's look at this one. We have 8 minus I plus 5 plus 4i. Well, if we have an addition sign in between here, that just means that we can drop the parentheses and combine our like terms. So if I'm thinking about what I have for like terms, my real numbers are 8 and 5. My imaginaries are negative I and positive 4i. So if we put together our real numbers, we're going to have 8 plus 5 is 13. Plus, we'd have negative I, so that's like negative 1i, plus 4i is 3i. And when we write our answers, just for the sake of class kick and consistency and things like that, we are going to put the real first and our imaginary second. Okay? The second one here is erase that little mark, is a subtraction problem. Okay? Again, we have to be careful with subtraction because when we have subtraction here, we have to remember that that subtraction gets distributed to both parts that come after it. So that's 7 minus 6i. Nothing happens to that. But if we subtract, if we distribute that negative, we'd have minus 3, and then minus a negative 6i is plus 6i. And then when we put our like terms together, our real is 7 and negative 3. And our imaginary is negative 6i and positive 6i, which means our reals, we would have 4, and then negative 6i and positive 6i would cancel. So all we're left with is just 4. Okay, let's just do a couple more real quick here. We have 13. We need to make sure we distribute that negative just to what's in parentheses after it. So we are going to have 13 minus 2 minus 7i, because I distributed that negative, plus 5i. And then I look, I'm like, okay, here's a real, here's a real. Those two are both real. And negative 7i, positive 5i are both imaginary. So 13 minus 2 is 11. Oops, 11. Minus 2i, because if you combine those like terms, negative 7 plus 5i is negative 2. One more with just some subtraction to make sure we remember that negative gets distributed to both parts. So I would have 16 minus 9i minus 2 plus 9i, again, because we distribute it both times, it changes the signs. So then our like terms, we've got 16 and negative 2 are like terms. And then we also have negative 9i and positive 9i. And what that means is we have 16 minus 2 is 14. And then our i's are going to cancel, so we are just left with 14. Okay, and then the other thing we are going to do with this is we are going to multiply. And when we multiply, we are either going to use the distributive property or the box method. So if we look, and again, down here it reminds us that I squared equals negative 1. So if we ever end up with an I squared, we are going to take it out, use substitution, take out I squared, and put negative 1 in its place. So let's look at this first one. We don't need to use the box method. We can just use the distributive property where we are distributing 4i to both pieces here. So 4i times negative 6 is going to be negative 24i. And then 4i times I, that's an I there, we get plus 4i squared. And remember, I said that anywhere you see an I squared, we are going to take it out and we're going to put a -1 in there. So we'd have negative 24i plus 4 times -1. Because again, oops, daisies, I did not mean to do that. I meant to highlight that. There we go. So when we go to simplify, we would have negative 24i. 4 times -1 is -4. But when we go to put our answers in class kick or anything like that, we need to make sure we put our real number first, our imaginary number second. Okay. Second one, this one we are going to need to think about using the box method on because it's a 2 by 2. So let's go ahead and I'll make a nice box here. We learned how to do the box method the other day. We have 9 minus 2i and then -4 plus 7i. Okay, and then we're just going to use our grid and we are going to multiply. -4 times 9 is -36. -4 times -4 times -2i is 8i. 9 times 7i is 63i. And 7i times -2i is -14i squared. So remember what we said? I squared is equal to -1, which means this box right here is going to be -14 times -1, which is actually +14. So the value that's in that box is +14. So when we go to combine our like terms are going to be -36 and +14. And then we are also going to have 63 and 8. And we're going to put our real numbers first. So -36. -36 plus 14 is -22. And then our I terms, our imaginary ones, are 63 plus 8, which is 71, sorry, it's not 72, 71i. Okay, let's just look at a couple more examples. Okay, why don't you go ahead and maybe pause the video for a second and try these 4 on your own. And then when you get done with trying those 4 on your own, go ahead and come back and then you can check that you are correct. So pause the video and try them on your own and then come back and check. Okay, so this is what I came up with. Check with what you have and make sure that you are correct. And when you are all done, make sure that you submit your lesson video notes. And there is a class kick to work on. Okay, have a good day.